reflection over the line, y equals x. Suppose you are asked to reflect a point over that line. Let's first plot the line. So y equals x. That's the line, y equals x. Let's make the line thicker. Yeah, it's black. Let's have it remain black. Alright, that's the line, y equals x. Alright. Now, as an example, we have the point 5, 1, which is right here. Let's call it P. When it's reflected over the line y equals x, it will be in this form. P prime will be at 1, 5. Now, here, what we have here is like this square, which I'm drawing dashed lines. It will become like this square. In other words, or another way to look at it, a line perpendicular to xy to P would be reflected over xy to another line perpendicular to xy to P prime. Alright? So that's what we would have. Now, P is at 5, 1. So let's change our color a bit. So 5, 1 becomes 1, 5 after reflection by 2 by 2 matrix. The thing now is, what is that 2 by 2 matrix? Can you figure it out? What could it possibly be? Pause the video and see if you can figure out what that 2 by 2 matrix is. So go ahead now and pause. Okay, you've paused the video and you figured out what the reflection matrix is over the line y equals x. Let's see something here. Suppose we have some numbers in here, right? And these numbers are A, B, C, D. You know, A by 5 in this case. Alright, where should we do it? Let's do it up here. A by 5 is 5A plus B by 1, which is 1B. Let's put the 1 there. 1B equals 1. Now, what we have, it seems like A is 0 because there's no trace of 5 up here. A is 0. So A is 0. B times 1. It seems as if B is 1 because 1 times 1 is 1. Alright? So B is 1. So far we see that A suggestion here is A is 0 and B is 1. What about C and D? C times 1, so 1C is equal to, no, 1C plus, I should say, or C by 5. What am I saying? It should be C by 5 when you multiply it out. C by 5 is 5C plus D by 1, 1D is equal to 5. This seems to suggest that C is 1 because you multiply 5 by C, you get 5, and there's nothing else, so D is 0. Right? So if you say C is 1, D is 0. Now, Let's test it and see if that's going to really be the case. So A is 0, B here is 1, C is 1, D is 0. I wrote A here, it should be 0. A is 0. So 0, 1, 1, 0. Let's see, 0 by 5 plus 1 by 1 is 1. 1 by 1, no, 1 by 5 is 5 plus 0 by 1 is 1. What we want to do is reflect a different point and see if it works out. First of all, we see that the reflection matrix over the y-axis is 0, 1, 1, 0. Would it work on all points? Let's erase these things over here. And what we'll do is perform the reflection on a triangle. Alright? Let's use a triangle. We want the points on the triangle to be -3, -1, 2, no, let's make it 5, -2 and 2, -4. The original triangle is this. We have -3, -1. So A is at -3, -1. Let's draw it up here. A. I'll write it up here. A is -3, -1. B is at 5, -2, 5, -2. C is at 2, -4. What we're looking for is A prime, where it is located, B prime, where it is located, C prime, and where it is located. All right. So we're going to just do the calculation, then draw the two triangles. All right. So 0, 1, 1, 0 multiplied by -3, -1 is equal to 0 by -3 is 0 plus 1 by -1 is -1. 1 by -3 is -3 plus 0 by -1 is just -3. So what we have here is -1, -3. So you're seeing that we're interchanging x and y in each calculation, right? So we can see that that's what's happening. Let us work on B now. B is at 5, -2. 0 by 5 is 0 plus 1 by -2 is -2 up top. 1, that's in column, in row 1, I mean. 1 by 5 is 5 plus 0 by -2 is 0, so that's in row 2. So we have -2, 5. And then C prime. Let's multiply 0, 1, 1, 0 by C prime. What we have for C is located at 2, -4. 0 by 2 is 0 plus 1 by -4 is -4 plus 1 by 2 is 2. 0 by -4 is 0. So we have -4, 2. Alright. So on the left we have the original points. On the right we have the image after reflection over the line y equals x. So let's erase these points are these right things and plot the two triangles. Let's first plot the original triangle. Let's plot it in red. We have our original triangle, -3, -1, point here, 5, -2, so we have 5, -2 here, and 2, -4, 2, -4 here. Now let's close the triangle. So we make some adjustment on each side. Let the color be red, and we thicken the sides. Well, it looks more like pink, but anyway, this side same color and make it thick, and then the third side we'll also give it that same color and make the side thick. Nice. Let's plot our second triangle now. So we have -1, -3, so -1, -3, it is here, -2, 5, so that's -2, 5, which is way up here, and -4, 2, -4, 2, it is here, and then we close our triangle. Let's make our adjustments now. So we have, let's make the color blue, and the side thick, this here, we make it that same color blue, and we thicken the side of it, and we do the same thing to the third side. Okay, so there we have it. The pink triangle is reflected over the line y = x to the blue triangle, and you can see that this point reflects over it and comes right here. I'm trying to make my lines straight. This point is reflected over and comes here. This point is reflected over and comes here, right? Oh no, this point is reflected and comes here, right? So let me do that again. It's the pink over, pink is reflected over to the blue, so this point goes here that way, this point goes here that way because it's on this side, and it goes over to the other side of our mirror line y = x, but this side up here comes down this way, it's reflected on the other side. All right, so there we have it, reflection over the line y = x.